Hello everyone, Victor is here, your organic chemistry tutor, and today I have a very simple question for you. Is the molecule depicted on the screen called coronene, is this molecule aromatic? Well, in order to answer that, we need to first remind ourselves the criteria of aromaticity. In order to be aromatic, molecule needs to be cyclic, planar or flat in other words. Molecule needs to be fully conjugated, so every atom within the cycle needs to be sp2 or sp hybridized. And we need to have 4n plus 2 pi electrons, which is known as the Huckel's rule. Well, let's look at our molecule. Is this molecule cyclic? Well, obviously it is cyclic. Is it planar? Like most molecules of this type, it is going to be planar. Is it fully conjugated? Well, it looks like every single atom that we have here, every single carbon, is sp2 hybridized, so yeah, looks like it is fully conjugated. Now, when it comes to the electrons, I have 2 electrons here, 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 and here, and also we have 2 more electrons per pi bond in the middle, so overall, if we calculate all of our electrons, then the sum of all of my electrons is going to be 24 electrons. Well, let's see if it fits the 4n plus 2 formula. 24 equals 4n plus 2, and for as long as the n is the whole number, any kind of integer from 0 to infinity, then we have the correct number of electrons and the molecule is going to be aromatic. Well, and if in this case I do my simple kindergarten algebra, I'm going to end up with 22 equal 4n, which means that from here we are going to have n equal 22 over 4, which is 11 over 2, so that does not give us a whole number, which means that we do not have the correct number of electrons. Well, we also remember that if a molecule has 4n electrons without the 2, that is going to be anti-aromatic. Well, in this case, I have 24 equal 4n, and that would be true if n equals to 6. So does that actually mean that coronene is anti-aromatic? We know that anti-aromatic compounds are extremely unstable and we cannot just easily isolate an anti-aromatic compound, and coronene not only stable, but it is actually a naturally existing mineral. You can Google coronene and you will see that we have coronene as deposits sitting as a stone in our earth in different places. So how come this molecule, which is supposed to be anti-aromatic according to all of our rules, is a perfectly stable natural mineral that is, well, definitely not breaking apart or being a biradical or anything of that sort that anti-aromatic compounds usually are? What's going on here? Well, the trick is, when it comes to polycyclic hydrocarbons like that, the guys that look like honeycomb, they kind of have a mind on their own, and the molecular orbitals within this molecule will rearrange themselves in such a way as not to be anti-aromatic. And what happens with this molecule is that the inner ring that I have right over here and the outer ring that we have out there, they are actually independent of each other. And if we count the number of electrons within each ring itself, the inner ring, this ring, is going to have 6 electrons, while the outer ring, that one is going to have 18 electrons, both of which are perfectly aromatic. And since 2 aromatic rings here, one nested within the other one, they do not interact with each other, we cannot count the total number of electrons here anymore. We have to treat those 2 rings as completely separate entities, which means that now we can easily have 2 aromatic things nested within each other and the molecule is perfectly stable. Is this the only molecule of its type? Oh, absolutely not. There is a whole family of polycyclic aromatic hydrocarbons like that. They behave in a similar way, where you are going to count the number of electrons and it will look like it's anti-aromatic, but in reality is not. Another famous example of a molecule like that is going to be something like pyrene, which is a pretty bad carcinogen, and it is found in both car exhausts and cigarette smoke. And there are many other examples of similar type of molecules. So if you have never heard about polycyclic aromatic hydrocarbons before, Google that. That's pretty fascinating Agreed. And when it comes to aromaticity questions, remember, molecule will do whatever it can to be aromatic or not to be anti-aromatic. So if it needs to rearrange its own molecular orbitals, it can definitely do that. And that's all I have for you guys for today. Thank you for watching. Let me know if you have any questions or feedback in the comments below. Remember to hit that like button to help promote this video so more students can see it. Subscribe to the channel for daily organic chemistry updates. Watch this video next, and I will see you tomorrow.